Alright, so check this out. Look over here. Courtney uses straws of different lengths to make these triangles. So here's the triangles. And here's the lengths that she used. So she has an 8 centimeter straw, an 8, and an 8. So it's almost like a triangle that looks kind of like this. Now, which of these triangles? Okay, and then she also had a couple other ones. She made one that has a 10, and an 8. 10, 10, 8. She made an 8, 8, and 8. She also made a 10, 10, 10. And she made a 10, 8, and 8.
So not all triangles like this one.
Which one of these has equal sides? Which one of these has at least 2 equal sides?
This one has more equal sides.
Okay. I want to know which ones. Actually, you know what? I want to know which ones have exactly 2 equal sides. But the third side is not equal. That one? Is that the only one? And that one. These 2 triangles, what do you notice about them?
They have 3 equal sides.
3 equal sides. This right here is called an equilateral triangle. Does that make sense?
Yeah.
Equilateral triangles have all the sides to be equal. An isosceles, these 2 triangles right here are called an isosceles triangle. Isosceles triangle have it so that only 2 of those sides are equal, and the other one is not equal. Does that make sense?
Yeah.
Okay. Let's see, I need to do 62, page 62. Oh, okay. So, say we have an isosceles triangle. Here's an isosceles triangle. Which sides are equal?
These 2.
Okay. And which side's not equal? The big
Half.
one. Okay. But if you fold this isosceles triangle in half,
And it's all. That's still isosceles. Right.
what do you notice about this angle right here and this angle right here?
They're acute.
They are acute. But when you fold them in half, what can you tell me about them?
They're equal.
They're the same. So look, angles opposite of the equal side. So look, let's look back at the isosceles triangle. See the isosceles triangle? Those 2 sides are equal, yeah? This angle right here is opposite to that equal side. And this angle right here is also opposite to this equal side. You're not paying attention, you're playing around. So these 2 angles right here, what can you say about them?
They're both the same.
They're the same. So usually we kind of put a little dash right here and an identical dash right there. Just to say this angle is the same as that angle. Does that make sense? All right. Say that, let's see. Okay. Say that you have a triangle. I'll draw the triangle. This angle right here is 54 degrees. This angle right here is 54 degrees. Is this an isosceles triangle? Why not?
Yes.
Yes. Why? How can you tell?
Because it has 2 equal sides.
Yes, it has 2 equal
And it
sides,
has
but
2 equal angles.
because the angles are equal. Does that make sense?
Yep.
Okay. Let's see. An equilateral triangle. Let's figure out what the angle of an equilateral triangle is. Here's an equilateral triangle, at least the best I can draw. An equilateral triangle has these 2 sides to be the same, right?
Yep.
So what can you tell me about this angle right here?
They're both the same.
They're the same. But it also has this third side to be the same. So what can you tell me about this angle up here?
It's the same.
They're the same. Okay. Now, if this angle is equal to that angle is equal to that angle, let's say I don't know what that angle is. Let's call it x. This is also x, and this is also x, right? And if I add them all up, what should I get? 180, exactly. So 3 times x, which we don't know what it is equal to 180. How do we get rid of the x? Or how do we get rid of the 3?
You divide it by you divide 180 by 3.
Good. So x is equal to what's 18 divided by 3?
Oh, 6.
Good.
So it's 60.
Good. X is 60. So, all angles inside here is exactly how much?
60.
60, because 60 plus 60 plus 60 equals 180. So, all equilateral triangles have angles of what?
Equal.
Well, yes, they're equal, but they're specifically, all of them are 60. Because that's the only angle that will give you 60 plus 60 plus 60 gives you 180. Does that make sense?
Yep.
So when I drew one triangle that had, like let's say this is an equilateral triangle as well. This had 10 centimeters, 10 centimeters, and 10 centimeters. And over here, our original one had like 8 centimeters, 8 centimeters, and 8 centimeters. What can you tell me about the angles of the bigger equilateral triangle?
They're 60.
They're 60. What about a smaller equilateral triangle?
Still 60.
Still 60. 60, 60, and 60. Does that make sense? What about a really small equilateral triangle?
60.
Adding up all these angles inside here, here, and here would be 60. As long as they tell you it's an equilateral triangle. Does that make sense?
Yeah.
Okay, let's see.
That must be some tiny protractor.
Yeah, you would just have to have a tiny protractor. All right, I'm going to draw something for you. Okay, here. Let's do this one. You got it? Look. A, B, C. I'm going to tell you that this is 35 degrees. Okay. I'm going to draw a line here and a line here. What does those lines mean?
That means that they're equal.
That
So
means
that's
this side's equal to
35,
that. That means that side's 35. Good.
And that one is. I don't know.
Well, we know that what is 35 plus 35? What's 30
That's-
plus 30?
70. I mean, it's 60.
And then 5 plus 5 is?
70.
Okay, 70. So we know that this is 70. So what does this have to be?
It's gotta be. Maybe 110?
Perfect. Because 110 plus 70 is 180. And you know that all the angles inside of a triangle, be it an isosceles triangle, an equilateral triangle, an obtuse triangle, an acute triangle, a right triangle, all have to add up to be 180. Does that make sense?
Yep.
All right, good.